Hi everyone, please take your seats. I know there are a few chairs left in the front and some in the back.
Yeah, that's right. I was already using
You can always sit on the sofas in the back or on the floor, wherever you
Just
want.
socializing here.
Can you hear me well?
I can't talk about it.
Yeah.
I suppose I should.
Can you hear me?
I need to
Okay. It's very soft, right? Maybe a little. No? Okay. So first we're going to start with O'Reilly Media with Kathy, who is here today, and she has some books to give away. So for those of you who gave your business cards, we can give you some books. How should we do that, Kathy?
Can I still
She's
put it?
just out from Strada. Who went to Strada conference last week? Who had Strada?
Oh, great. So I have 5 books. I have 5 books here. So what I'll do is I'll start picking names, and then the first person will choose one of 5 books, and then the next person will choose one of 4 books, and so on. Okay, the first winner is David Lai.
Yes.
All right.
So we have a Hadoop, the definitive guide using Flume, Impala, machine learning, and PostSQL up and running. All right, thoughtful machine learning. All right, congratulations. No, you have to.
Okay. Oh, Dragos. Where are you? Here. Yay!
All
From
right.
Stockholm.
So Hadoop, Impala, Flume. Yes.
Great, congratulations. Thank you.
Oh, no, just go on. Just one per winner. Okay. You, Kathy Chang. Scaling data. Impala.
Alan Ho. Yes. Choice is going to be hard.
I know, there's only 2
I'll choose the Hadoop book.
Okay. So we have the last winner. And Try Gwen of Live Talking is
Yes.
Try Tree.
He's talking in the back. Can you
Um,
repeat the name?
Tree Gwen.
Yes. You already won last week.
Oh, he did.
Yeah, the
Okay.
Beats headphones.
Oh.
Did I win a Tesla or not? Thanks. I thought I won at least an iPhone, iPad. Thanks, I appreciate it. Thank you. Thanks.
Thank you. Thanks. Thanks, Kathy. Okay, so just a few words very quickly. I know we have an amazing panel of speakers, so I won't take too much of your time. My name is Pashu Christensen. I'm with the Hive, and I would like to welcome you tonight to the Hive think tank, the largest big data community in the US with over 6,500 members. We've hosted over 100 events, 200 speakers, so thank you for being part of this community. These are our upcoming events, so take good notes and register as soon as you can because our events fill up very quickly, as you can see. We'd like to thank our sponsors tonight, especially NetApp for hosting us. our partner Oral Media for being here. I know we have a few people from Teradata. I see Aerospike here with Peter. And so thank you to all our sponsors who are here to support us. And with this, I'm going to give the microphone to TM Ravi, the founder of the Hive. But first, please make sure to continue the conversation online tonight using the hashtag Hive data. Thank you.
Thank you, Pashu. So the Hive is a funding entity. We fund companies that are building applications and use cases driven by data. So reach out to us if you're an entrepreneur or if you want to join one of our companies. Be a part of the community today that's part of the conversation. So use the hashtag HiveData. And with that, I'd like to, so the way we are going to be structured today is Alan here from Teradata is going to speak for about 10 minutes on essentially a use case of Lambda architectures. And then I'll pass it over to Ben, who will then introduce the panel and get the show started. We will probably save the Q&A for the end, Ben? Is that how it's going to work?
Yeah.
We'll save the Q&A for the end.
Great.
Great.
Okay, thank you.
Let's see. Wait, everyone can hear me? All right, my name is Alton Kenda. I happen to be the leader of Teradata's Unified Data Architecture COE, Center of Expertise. So a little bit redundant, but that's how our name ended. So we happen to be in our group responsible within Teradata working with various parts of the organization, such as Think Big and our existing stacks, and helping customers with their challenges related to big data. And one of them that we're speaking about today is about the Lambda architecture. So this is a little brief background of the Lambda architecture. I'm pretty sure everyone here is fairly familiar, so I'm just going to go through this fairly rapidly. But a little bit of the background is it's a reference architecture for big data systems designed by Nathan Mars. It has a few design principles as shown on the slide in regards to being immutable, fully computable and recomputable, and human fault tolerant. And it basically has a layered approach. So a real-time layer, a serving layer, and a batch layer. So dealing with real-time events and data, basically dealing with cold or historical or more long-lived data in the batch, and then serving that up in the serving area. So this is our representation of Lambda architecture. You'll see a lot on the internet, you'll see a lot in other areas, but this is how we at Teradata have viewed the Lambda architecture, specifically around each of the layers and how they actually operate together. And specifically around the idea of dealing with a variety of different views of data from the computations, and really around the idea of focusing the data around a variety of queries that are coming into the system, which are called query focused data sets, or the QFDs. So if you see that little strange acronym, that's what that means. So in regards to Lambda architecture, we've actually implemented it at Teradata successfully at several customers. And one of our main ones that we talk about quite frequently happens to be in the healthcare industry, specifically with the Mayo Clinic. So a little bit of history about the Mayo Clinic as far as an organization. They work with more than 1 million people from all 50 states and over 150 countries for care. They have a variety of locations here in the United States with major campuses in Rochester, Scottsdale, and Jacksonville. And they're also one of the world's most globally recognized organizations in terms of healthcare, being one of the largest for nonprofit and for improving the human condition. So from their perspective, why did they choose big data? Why are they even concerned? So like most organizations, they're just dealing with a lot of data. And the challenges in their domain, especially around medical data, is that it tends to be wide, not necessarily deep. And they're dealing with a lot of new types of data. So a lot of unstructured and a lot of real time, from medical sensors, from things such as MRIs, a variety of things are now coming to their domain that they need to be able to take advantage of. Also, from a perspective of taking advantage of it, their typical BI tools, their typical way that they approach it, have basically been challenged in dealing with this new data effectively for the business. Mainly because there's a lot of multiple layers to the data, lots of events related, and a lot of data, period, in terms of the numbers and types. It's very complex. There's a lot of different languages and different data structures that they're working with, so it becomes very difficult to maintain. Some of these are related to specific technologies, to the industries, to what they're doing related to regulation. Also, there's a lot of, in regards to coordinating this, there's a lot of moving pieces and components of technology. So this ultimately boils down to a huge challenge to Mayo in terms of how to deal with it. Their main perspective of working with big data happened to be putting that in relation to data discovery. So a lot of companies and a lot of organizations look at discovery as a form of experimentation, interesting to look at algorithms, to refine models. In the case of Mayo Clinic, discovery, they understand that advantage, but for the most part of what they're looking for is actual true value to their patients and to the people that are in their care. So this is, to them, it was going beyond just an experiment. It actually dealt with human lives. So the overall project that we were engaged with Mayo was to basically work with an existing natural language processing system that they had in place, dealing with a specific area of research, specifically colorectal surgery. And what they're really looking for is how to basically replace an existing system so that they can actually help gain information much more quickly and rapidly to the various groups that consume it. So here is how they ultimately decided to deal with the problem. So there's actually, this is the end state diagram, but the reason why all of these complexities, all of these areas that they had to deal with and challenge, Lambda architecture was something that was actually not in their foremost thought. It was sort of, we're gonna build these things, we're gonna build this area, we're gonna have an area of real time, we're gonna have an area of batch, we're gonna have a serving layer that serves all of these up. And they came quickly to the realization that, hey, we're actually building something that's actually fairly technically sophisticated. So in this particular case, this diagram, and it's very simplified, but essentially what they're taking is a variety of different sources of data, all medical systems coming into essentially what they call their big data platform, and dealing with it in a variety of real-time ingestion mechanisms, specifically with Storm. It has a lot of work and interplay with Hadoop on the HDFS for historical, and also expressing that inside their search applications, which they chose as Elasticsearch. One of the things that you see here on the far right happens to be that NLP. So one of the areas where Mayo has a very good advantage is that they have a very strong natural language processing group, and they actually have created essentially custom dictionaries to express data and a common data language. So this was actually stored within this area on to the right. That was what they were using to basically work with complex event sets and making sure that they're consistent across the entire ecosystem that they created. From that common linguistic, they're able to then basically provide the result sets out and place them into more traditional structures, such as relational databases or search components. And these basically were then provided back to their various applications and systems. The results of their initial area, and this is actually from about middle of last year, so they're able to basically process up to 1.5 million medical documents per hour. So these are documents of varying sizes, types, and different groups. They're able to deal with approximately 140,000 medical messages in HL7, and they're able to go through that entire diagram from the lower left to the expression to the customer in about 60 milliseconds through all of those areas. They also have seen a lot more in terms of the annotations. So that's one area I could have skipped, but when their researchers actually look for cross-references for history related to their areas going all the way back to the 1850s, it was very, very laborious. And this process allowed them to actually do about 10 times that in the automated sense. And the last one happened to be about their free text search. They had simply like a Google-like interface that they constructed on Elasticsearch. And their old system was coming back with results in about 30 minutes or more. The new system now comes back in a few milliseconds and completely accurate. So in their area where Mayo Clinic really saw the benefit of this architecture and working with Teradata happens to be, they now own that stack. This is not something that they're purchasing. They've actually gained it all together internally. They also have great continuity and it supports their existing ecosystems. So they see a lot of benefit. It was challenging, but they see a lot of benefit. And that's really the end of the use case in this case. And as you can see, my name is Alton Kenda, having the present, and Ron is on our panel. So thank you very much.
Thank you, thank you. So with that, I'd like to get the panel going. What an amazing panel, by the way. We have Patrick, Jay, Ron, Jay, Eric, and of course our moderator. Ben is at O'Reilly Media and is the chief data scientist, the chief content guy, and spends much of his time on the overall sort of data science and data infrastructure space. With that, I'll hand it over to Ben.
Thank you.
All right, thank you to the Hive. As they mentioned, we have an amazing panel. On this panel, we have some of the people who created the technologies that we've all come to love and use. So one thing to note is we'll set aside a lot of time for Q&A towards the end. So you'll have a chance to address each of these fine panelists individually. So at O'Reilly, as you guys know, we put on a big conference in data called Strata plus Hadoop World with Cloudera. And at the end of the day, when we create that program, even though we're big fans of technology and individual components, open source components, we know it's all about helping individuals and companies make better decisions. And increasingly, a lot of those decisions rely on real-time information. Hence, our interest in the Lambda architecture itself, the topic of this panel. But one thing to note, when we did our planning for this panel, we did realize that the panelists themselves are also interested in real-time and stream processing in general. So we'll start with the Lambda architecture, but we'll morph the discussion more towards more general topics in stream processing. So I hope that you find it interesting. So with that, I'll let these gentlemen introduce themselves.
Sure. How long of an intro? 30 seconds?
Patrick, you can go to the.
What's that?
Your presentation is in the computer.
Oh,
If
you
you
know,
wanna
I'm
do-
gonna skip the presentation and
Okay.
just talk.
Sounds good.
Yeah, I'll go quickly. I'm Patrick Wendell. I am a co-founder of Databricks, the company that is from the creators of Spark, Apache Spark. I was working on Spark at the Berkeley Amp Lab doing my PhD and then left to start the company around 18 months ago. I approached the kind of stream processing, continuous processing problems through the lens of Spark Streaming, which is a streaming component we have inside of Spark. I worked on that and wrote the Java API and did some work there. So that's kind of where I approach these types of problems.
Okay, and I'm Jay Ranganathan. I'm from Cloudera. I'm definitely the less famous Jay in this panel, but so my interest here is the fact that I've actually been talking to Patrick for 2 years, and I've been involved in Spark for a long time, and as part of my role at Cloudera, we've been seeing an increase in uptake in the amount of real-time data processing requirements that come to us. Therefore, we actually recently added Kafka, which we did in collaboration. Jay helped us out a lot on that as well. And we support Spark Streaming as part of our architecture as well. And both of these technologies have started taking a huge amount of increase in the way they're being used in our customer base. So, I'm going to talk about that as well. I'm a product manager, so if you have really hard technical questions, you should definitely ask me. I'm the best person to answer those kinds of things. So, okay. Go ahead.
Okay. So I'm Ron Bodkin. I'm founder and president of Think Big, now a Teradata company. So I started working in big data back in early 2007, 8 years ago, at a company called QuantCast that was the first company to try to directly measure the internet, and went on to lead the data science and engineering teams that built real-time lookalike models, so large-scale models for targeting ads online. So I left QuantCast back in 2010 and started Think Big, got the band back together with some folks who'd been senior people at a internet company, services company, Seabridge, and we've scaled Think Big. This is kind of a nice historical place for me in a sense that one of our first big customers was in fact NetApp, and I spent many lunches here in this cafeteria helping them with one of the first large-scale deployments of a Hadoop-based system for Internet of Things analytics. And at Think Big, we've always recognized that operationalizing analytics and having real-time capabilities is important. In fact, at QuantCast, we had to build a lot of those same types of capabilities. So we have a lot of experience and perspective. Lambda, when it came out, I think was a term that really caught people's attention because it crystallized some of this notion of how do you use an ecosystem of technologies. But I think in the panel today, we'll see how some of these technologies are evolving, and the patterns are evolving so rapidly. It's one of the great things about an open source community. So I'm looking forward to the discussion today.
Cool.
Jay?
Yeah, shall we do that? All right. Hi, everyone. So my name is Jay. I until very recently was working at LinkedIn. I was the one of the lead architects for data infrastructure. I worked on a bunch of things there, including a key value store called Voldemort and Kafka, which is a kind of big distributed message bus. And one of the things we did at LinkedIn was kind of put this at the center of everything and take everything happening in the company and capture it as a real-time stream. And so we got this really interesting opportunity to find out what happens when you can take a whole company and take every click and every action and every time you restart a process and all the changes coming into databases and turn them all into streams and kind of make them open for everyone to process. And it was actually pretty awesome. It turns out once you have a bunch of real-time streaming data, you immediately have a lot of real-time processing. So the result of all that was we definitely got to see a lot of different kind of architectures or patterns for real-time applications, including Lambda architectures and non-Lambda architectures and different varieties of all that. And we kind of crystallized this idea of having some kind of platform for streaming data, and we thought Kafka could be a really big deal for that, and it could be this hub for stream processing and real-time analytics and monitoring and feeding all these other kind of weird jungle of data systems, including of course Hadoop, which is maybe one of the most important things to feed. And a bunch of companies started doing this. We released this as an open source project, so it's used kind of all over the place these days. And very recently, I left LinkedIn to start a company that is kind of trying to take this idea and make it a little easier to do. All these big tech companies that were doing it, had a team of 10 people that was doing Kafka adoption and instrumenting all the systems, and that seemed like kind of a lot. And they all built in-house some set of tools that we had at LinkedIn. We thought, well, we should just make these part of the platform. So that's what we're doing. We just released some software. If you go to confluent.io, you can find out about it. There's a blog there. And I also wrote some stuff about real-time data and logs that's also available.
From O'Reilly.
From O'Reilly, yeah. You should definitely buy the one from O'Reilly, not the one online that's a blog post.
So hi folks, Eric Balderschwiller. Depending on how you look at it, I either have a lot or nothing to say about Lambda architecture. I started in big data in '96 when we wanted to build search engines, Ink2Me, and then Yahoo. So I was responsible for crawling and indexing all the data on the web, which is kind of a big data problem. And that work led into Yahoo's Hadoop project, where we coordinated and ran the releases of basically every version of Hadoop up until 2011, where we spun that team off into Hortonworks, where again I was the founding CEO and then CTO of Hortonworks. So I've seen a lot of Hadoop, and that's kind of the intro. And do you want then to move into a use case, or?
Sure. I guess he.
Or we can just leave this slide
The
here.
previous speaker kind of covered what is the Lambda architecture, but since you're up there, Not many of you know, but Eric is now advising several startups, right? So, is this architecture something that comes up in any of the companies you talk to?
Yes, of course. Data streaming more generally is, of course, very interesting to a lot of folks, and I'm advising Spark, which you're going to hear about a lot tonight, and DataTorrent, which is another streaming company. And also, both Hortonworks and Yahoo are now big users of the Storm itself. So I've seen a lot of these things in use. Do you want to?
So so actually you can cover this first, the example from Yahoo.
All right, so looking back, this is sort of one of the very first big Hadoop applications at Yahoo, which led to a very Lambda-like architecture. And so the problem was, how do you customize every web page that you serve to every user with information that's relevant to them? So the problem, there's a big data science problem, right? You want to look at every interaction everyone's ever had with Yahoo, and from that try to infer what they're interested in. You can do that monthly, that's easy. And you can build models then to try to take the information that you see every day from people and infer their interests. Okay, if somebody is viewing articles on cats, we should show them more information on cats. If they like cars, let's show them information on cars, right? So you want to infer users' interest and give them relevant content. But of course, what you find out very quickly is that you get more engagement, more relevant interaction with the user if you learn quickly, right? If somebody just did 5 searches relevant to vacations and travel, probably now's a good time to show them articles and advertisements on travel. So the faster that you can infer somebody's interest, the faster, the better the experience you can provide to them. So what we saw was this sort of 3-tier system evolve, where at the top, okay, I'm not going to try to use the pointer. At the top, there's this sort of monthly process where you would look at everything that had ever happened on Yahoo and build a better machine learned model to you'd sort of improve the application itself. And then every 15 minutes or 5 minutes later on, we would look at everything that you've done on the site, run a machine learned algorithm on Hadoop, and put the authoritative classification of your interests up into this serving system here. Today, that serving system would be something like Cassandra. Back in the day, it was a hand-built system. And then every time a user visits the site, you look into that database, you say, okay, this person has interests in cars, cats, and sports. Let's see what articles are currently available for that, and you build the front page for that content. But so 5 minutes, it turns out, is much too slow. What you want to do is be able to show them a new result every time they visit the site. If someone visits the site and clicks on a link, the next time you paint a page, you want to have more information. So the question became, how do we both do something in batch and also do something immediate, learn instantly. So in those first applications, that was hand-built. That was just custom code that was built right into the application, right, where we would go and edit the Cassandra tables, or Cassandra equivalent tables. We just had rules. If somebody visits this section of the site, tag them as interested in autos if it was the auto section, etc. But over time, that's become more sophisticated. So what's kind of emerged is this architecture, which I've talked about a few times, which, again, you could say this is the Lambda architecture. You could say this is just how people build sort of sophisticated applications using Hadoop and other tools. So what you see is up at the top, your typical LAMP stack, right? You have your stateless, your Apache servers, Tomcat, whatever. So the user interacts with the website gives them pages. To build that, the website only has to consult real-time data sources. So it can't go to Hadoop. It goes to some kind of serving store, like Cassandra, MySQL, you name it. But you also want to do all this learning. How do you do it? Well, so you have the messages go into a message bus, something like Kafka, and then you fork those messages. This is just log events. The user visited a page. Every time the user visited a page, the user clicks on a link, that goes down into your real-time bus. And then it goes into two places. It goes into your sort of streaming layer, your fast track, where you use something like Storm, Spark, Sansa, Data Torrent, to come up with, next event, sort of immediate per event results. Right, so here you can accumulate information if you're building a dashboard, okay, more users went to the site, or in the case of this classification, you can say, aha, we've seen that the guy's interested in, autos today. Let's go edit Cassandra right now and tag that so that the next time he comes to the site, we can show him more articles on automobiles if that's his interest. And then also every link goes down into your classic Hadoop stack where you do your more elaborate machine learning. So that's kind of a pattern that we've seen emerge. Like I said, we were doing this in 2008. And I think Ron was doing similar stuff at about that time.
So I think
so this is kind of what we've seen. And so the Lambda architecture is just a codification of that. And I think you see kind of the same things here, right? The speed layer and the batch layer and the serving architecture. So like I said, that's how we got there, and we're seeing that emerge codified different ways in different architectures.
All right, great, thanks. So I think I'd like to start by making sure that this is not just one of these San Francisco Bay Area things, right? So that it doesn't really play out in the rest of the country. So let me ask Jay here from Caldera, is this something that you see in, you guys have lots of customers now, Caldera?
Sure. At a high level, what Eric said resonates really well with me, even though I'm technically supposed to disagree with everything he says. I'm saying that the pattern of the pattern of having a model which is scored in a fast way, basically in a streaming manner, while it's being built in a offline manner, is completely standardized across. I don't even think it's like new, independent of big data. Even in small data, you had to do this kind of thing. So that pattern has been very common. Obviously, the tools have improved, so you can do it at a larger scale than they used to be able to be done before. But that pattern is super common. We actually see that in a variety of industries. The example he gave, which is really like a recommender system, has the facet of also requiring a model update as part of that process, which is a little bit more complex than most of the cases we see, where it's really just like, hey, I built a model, I took the output of that, and whether that's PMML or whether it's hand-coded, I'm going to put that in my streaming system to actually look at the dimensions that are, look at the features that are relevant and actually coming up with the result for that. So in our world, we would say age-based, but at the end of the day, you have your features in a real-time store and you do your scoring as these things go by. That's a very, very common pattern that I see across many industries actually.
So actually, I'd like to follow up with Ron, because he also goes out there and does a lot of consulting with enterprise customers, previously with Think Big, now with Teradata. So is this...
Still Think Big, just a Teradata company.
Okay.
We're separate business units, still independent consultants.
So is this an architectural pattern that actually addresses a common pain point among your customers?
Yeah, so I mean, I think it's important that there's this notion of crawl, walk, run, right? Which is, getting to real time, is a journey, right? And maturing your adoption of big data is a journey, right? So a lot of times in the 20-mile radius of this particular building, we have a very different perspective of where the rest of the industry is in adoption, to your question, Ben, right? That absolutely some of the most sophisticated enterprises are looking to integrate millisecond type real time, but so often when we talk to customers and they say, well, look, I want to do real time big data. Well, what does real time mean for you? Well, it'd be nice if we had results updated every day, right? Or and some of the more sophisticated ones, well, every hour or 15 minutes, right? So the first thing is there's often a lot more value in taking things down to an hour or minutes than down to milliseconds, right? And the second thing is many organizations have no ability to work with their big data sets. And the first order of business is building a data lake and getting basic access to their big data before they get in there and start saying, let's operationalize machine learned models so we can automate our response. There's clearly value in the latter thing. And in some industries like in ad tech, it's standard operating procedure, right? And in most internet companies. But in a lot of industries, they've got a lot of homework to do before they're ready to tackle that. The other thing that worries me a little bit about streaming architectures is and the notion of Lambda is a lot of times people who don't know kind of what tools can be used for what gravitate to it because they think, well, if I'm doing real time, well, I better get a Storm or a Spark streaming and I better set up all this complexity of Lambda, when maybe their use case could be solved more simply and they can incrementally add complexity to their architecture. So that's another one that I see as a challenge out there, but absolutely it's relevant in the broader market, and we see adoption in financial services, we see adoption for Internet of Things, so there definitely are more sophisticated customers that are embracing it, but it doesn't mean it's the first choice. In fact, it's almost certainly not the first step you take in big data.
So speaking of complexity, so Jake Reps did play around with the Lambda architecture when you first read about it, from what I understand. So how would you rate the complexity of that Lambda architecture?
Yeah, I mean, I guess my involvement in this is probably before there being kind of a phrase to describe it, but we had like real-time data processing, and I guess if you do that, you kind of do it all the different ways. And I think probably just to clarify terms, I think if you're computing some model in Hadoop and then you ship it and you apply it somewhere else, I don't think that's the Lambda architecture. You're just batch computing some part of it, right? So I think to really be doing this thing, you have to be computing the same thing in two places. And we definitely did that at LinkedIn. I think there's still things that do it that way. Obviously, the challenges are you got to compute the same thing in two different places.
So sometimes the complexity might be worth it.
Yeah, so I ended up getting involved with this more just because I think, in talking to companies, a lot of companies were like, yeah, this Lambda architecture stuff is amazing. It's so great. We can't quite get it working. And I think it is a little bit complicated if you're spanning, you've got a real-time aspect, you've got a batch aspect, you got to ship data, you have to piece together results from both at the same time. And so I don't know if it's like the first tool I would reach for if I was trying to build a real-time thing. I don't think it's bad. I think it's good. I think probably for some applications it's the best way to go. I second everything that everybody else said, which is getting results is more important than getting results fast. So if you have no results, maybe you don't have to start with real-time. But yeah, anytime you're rebuilding the same logic in two places, there's going to be a lot of complexity in keeping that going. You can do a lot to patch that up and make it better, but it is going to be complicated.
So Patrick, I think from